In this video, we'll discuss hypothesis tests using T procedure. Let's look at the first problem. The sample size is 25. Immediately we know degrees of freedom is 24. We need to do a two-sided test, and that's clear from this. The alternative hypothesis has a not equal to, which means we need to do a two-sided test. The T statistic is given to us, which is 1.12. So we are halfway done, and we just need to do a little more to complete this hypothesis test using a T procedure. So we need to find the p-value for t equals 1.12 and degrees of freedom 25 minus 1, which is 24. So the degrees of freedom is 1 less than the sample size. Now we need to find the p-value. We look for degrees of freedom 24. So we go to the row headed by 24. And that row gives us the t distribution for degrees of freedom 24. We look for the number 1.12. Now we're not going to find that number, but we're going to find two numbers between which 1.12 lies, and it happens to be 1.059 and 1.318. So please keep the table C in front of you when you're doing this video, so that way you know exactly where the numbers are coming from. Now 1.12 lies between these two numbers. This is where t equals 1.12 sits. Now we go down this column and we go down this column to find the p-values at the bottom of the table, the two-sided p-values for these two t statistics. So the two t stars that we have here, we need to find the p-values, and the p-values for the p-value for 1.059 is 0.30 and 1.318 is 0.20. Our p-value lies between these two p-values. The next question says, is t equals 1.12 statistically significant at the 10% level? So in order to conclude for statistical significance, we need to know the p-values, and we know that the p-value lies between 0.20 and 0.30. Now, no matter what the p-value is, if we know it lies between 0.20 and 0.30, you know it's going to be somewhere between these two numbers. 0.10 is 10%, 0.10. So 0.10 is less than, so this is where 0.10 will be, somewhere outside of this interval. So clearly the p-value which lies somewhere here is greater than 0.10, which means we do not have a statistically significant result. So we failed to reject the null hypothesis. So t equals 1.12 is not statistically significant at the 10% level. Now 0.05 lies to the left. So 0.05, that's 5%, 0.05 lies outside this range of value. So it lies outside but to the left. So clearly the p-value is, which lies in this range 0.2 to 0.3, is greater than 0.05 clearly. So we do not have a statistically significant result at the 10% level and at the 5% level. Now here we'll do a T procedure, but let's read the question first. Phosphorus is a mineral that is essential to a whole range of metabolic processes as well as bone stiffening. Levels of inorganic phosphorus in the blood are known to vary among adults normally. So the amount of phosphorus in the blood is a normal distribution. That's what this tells us. A study was conceived to examine inorganic phosphorus blood levels. That's what we are measuring. So that's our measurement X. Inorganic phosphorus blood levels in older individuals. And the age group is 75 to 79. That's our a population, and we're talking about 12 men and women, so that's our sample size, n equals 12. So we're given the values, and clearly sigma not given. So sigma is not given, and that's important to notice here. Now let's read the question, and this is the question. It says, is it true that the average phosphorus levels among people in this age group is not equal to 1.47 millimoles per liter? So the question here is not asking us to estimate the mean, it is asking us to prove something. The minute we have to prove something, what we need to do is a hypothesis test. And since sigma is not given, we'll be doing a hypothesis test using a T procedure. So let's first make the statement, and the statement is, we will find evidence, because we're doing a hypothesis test, to show that the average phosphorus levels among people in this age group is not equal to 1.47 millimoles per liter. So we're making a complete statement, and the statement that we make is always proving something about the average of the population, which is mu. So we'll find evidence to show that mu in this age group is not equal to 1.47 millimoles per liter. So first we do a formulate. Sigma is not given, so we use a single sample because there's only one sample here. T procedure, so there's one measurement, and that is given by the 12 numbers that we see in the problem. So sigma is not given, it's a single sample, so it's a single sample T procedure that we're going to use. We do a hypothesis test because we want to prove something, and that's the reason why it's a hypothesis test. So we write down the formula, always formulate, always just end with the formula because that is a start. The formula tells us what values to look for and what we have and what's missing. So the formula is x bar minus mu naught divided by s over radical n, and when you enter numbers into the calculator, make sure you have parentheses. Now before we do anything in a hypothesis test, we need to write down what we are trying to prove, and that would be your null hypothesis with 0 as a subscript and your alternative hypothesis with A as the subscript for H. So H is just the name of the statement that we're going to make, the sentence that we're going to write down. So what is believed to be true is always the null hypothesis. What is believed to be true is 1.47 millimoles per liter is the average phosphorus levels in the blood, inorganic phosphorus levels in the blood of adults in that population. What we're trying to prove that mu is not equal to 1.47 millimoles per liter. So write this down first, and this number that you see in the null and the alternative hypothesis is the same. The null hypothesis always has an equal to, and the alternative could be greater than, less than, or not equal to. These two would be one-sided tests, and then this would be a two-sided test, because when we say it is not equal to, it could be less than or greater than. So we plug in all the numbers we have. So the x bar and s come from the calculator. So we need to enter all the numbers into the calculator and get the sample mean and the sample standard deviation. Mu naught comes from the hypotheses. The number that you see in the null and alternative hypothesis is the mu naught. And the sample size, n equals 12, is clear because we've got 12 individuals in that particular sample. So we enter all the numbers to get negative 4.32. Now all we have to do is find the two-sided p-value for t equals negative 4.32 using table C, that is the t distribution, with degrees of freedom 11 because the sample size is 12. Table C only gives positive t values, but because of the symmetric nature of the t-distribution, the p-values for negative 4.32 would be the same as the p-values for positive 4.32. So we look at the row headed by the degrees of freedom 11, and then we look at, so degrees of freedom 11, we look at the t-distribution for degrees of freedom 11. We find the two numbers between which 4.32 lies. You're looking for 4.32, but we're not going to find that in the table. So we look for two numbers between which 4.32 lies. And the next thing to do is to find the p-values related to the two numbers that we see in the chart. And our p-value will lie between the two numbers. Make sure that the smaller number is on the left and the larger number is on the right. So the p-value of t equals 4.32, which is the same as the p-values for negative 4.32, lie between 0.001 and 0.002, and we've looked for two-sided p-values. So that's how we get the 0.001 and the 0.002. It's not one-sided because our alternative hypothesis has a not equal to in it. So clearly these numbers are small enough. So this is 0.001 on the number line, and this is 0.002 on the number line, and clearly 0.05 lies to the right of these two numbers. So it lies, it's much greater than. So our p-value has to be less than 0.05, which means our t-statistic 4.32 or negative 4.32 are both statistically significant because they are less than our standard, which is our significance level alpha. So we reject the null hypothesis. So the significance level is 5% or 0.05. So we compare our p-values to the significance level and conclude that we can reject the null hypothesis. We have enough evidence to reject the null hypothesis. So our conclusion is we have very strong evidence. And why do we need to use the word very? Because our standard was if we got anything less than a 0.05, then we would say we have evidence. But what we got is way less than 0.05. This is a very small p-value. So that's the reason why I said we have very strong evidence at the significance level of 5%, which is 0.05, that the mean phosphorus levels among people of ages between 75 and 79 is not equal to 1.47, and that's exactly what we proved. Now, what are the important things you need in the conclusion? If you say you have evidence, you need to present the evidence. Make sure you present the evidence. That's important. The significance level, if you reject or fail to reject, people need to know at what percentage level you rejected or failed to reject the null hypothesis. You also need to mention the entire statement that basically says that you have answered the question that was asked at the beginning.